notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. These first 3 sections, all 51 videos, have been published in their entirety on YouTube. Section 4, measurement. All 17 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 5, statistics. All 18 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 6, algebra. This is where we are right now. This is the 11th of 22 videos, and hopefully by mid-September this should be completed. After that, we will go on to section 7, relations, functions, and graphs. Should finish that by October 2025, to be followed, of course, by geometry and trigonometry. Should finish that by November 2025. And finally, section 9, vectors and matrices, should complete the syllabus by December 2025. That is, by the end of this year. Disclaimer here, please note that this schedule is just a projection, which is not to be interpreted as a contract with anybody. As I just pointed out, section 1, number theory and computation, is made up of 33 videos, all of which have been published on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. So these 33 videos on the left there, please make sure you view all of them and learn them well. A reminder here, you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. From section 2, consumer arithmetic, all 12 of these videos have been published on YouTube in their entirety. Section 3, sets, all 6 of these videos have been published on YouTube in their entirety. Section 4, measurement, 17 videos. Out of those, these 5 have been published on YouTube in their entirety, as indicated by yellow here. The others are only partially published on YouTube. Please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 5, statistics, 18 videos. These 5 that you see indicated here in yellow have been published on YouTube in their entirety, and the others are only partially published on YouTube. Again, please see direction in the description below for full access to these videos that are only partially published on YouTube. And that, of course, brings us to section 6, algebra. This comprises of 22 videos. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get especially more practice questions. CSEC recommends the following, shown on the right here. Of those, please pay close attention to these last 2 down here, since they form a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math exam. This is a picture of volume 1, Mathematics, a complete course with CXC questions by Raymond Tusi. And this is a picture of volume 2. Disclaimer down here. Please note that I get no financial or other benefits from the sale of these books. Also, very recently, late 2024, I think, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from paper 2. You can navigate by topics or years, where all questions for the past several years have been worked out for you. If you still have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely that will be explained to you. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL of that website. On the next slide, I will show you the home page for that website. This is what it looks like. You will have to register first, and subsequent to that, sign in. This is the URL again listed on the top here. That URL will be in the description of this video below so that you can easily click on it and be redirected to this website. Another reminder, this formula sheet that you see here on the left, it is provided for CSEC math examination papers. There will be a link in the description below from which this formula sheet can be downloaded. Of course, if you have the full syllabus, this formula sheet is in that syllabus. A closer look, this is the top part of that formula sheet. Please note that you do not need to learn these formulae or memorize them, as this sheet will be provided during the examination. And this is the below part of that same formula sheet. And while you do not need to memorize these formulae, you do need to know how and when to use these formulae. Overview, Algebra 6. We have completed these 4 objectives in these 4 videos. Continuing with overview, we have completed these 3 more objectives in these 3 videos, 5 to 7. More overview. From this page, we have completed objectives 8 to 10, that is up to here, in these 3 more videos. So we are now at objective 11, this one down here. Objective 11, which is a continuation from objective 10. Objective 10, we learn how to solve linear equations with one unknown. In this objective, we will learn how to solve simultaneous linear equations with 2 unknowns. So it's an extension of the last video. And then after that, we still have these 5 more objectives to do, and that will be covered in videos 12 to 17. And finally, these last 5 objectives will be covered in videos 18 to 22. So we got this far to video 10. Out of those 10 videos, these 4 indicated in yellow here have been published in their entirety on YouTube, and these others only partially published. So we are now at video 11. When this video is completed, it will only be partially published. So as I said, we are now here, objective 11, this, which says solve simultaneous linear equations in two unknown algebraically. Introduction to this objective. I think of two numbers that we will call x and y. If I add them, I get 25. That is, x plus y is equal to 25. If I subtract 2 times x from y, I get 10. That is to say, 2x subtracted from y is equal to 10. What were the two numbers I thought of? Now remember, previously we were talking about one number. Notice we now have two unknowns, x and y. For two unknowns, we need two equations to solve them. And both of them are linear equations. Recall from the last objective, we said that in a linear equation, all the indices of the unknown terms are 1. If we were to plot these linear equations on a graph, we will get a straight line, hence linear. So let's get the coordinates and then plot them one at a time for these two equations we have up here. X plus y is equal to 25 and y minus 2x is equal to 10. So x plus y is equal to 25. If we substitute for x negative y, negative 4, and so on, right up to 7, we will get the corresponding y values. And if we do the same thing for the next equation, y minus 2x is equal to 10, we reformat that to y is equal to 10 plus 2x, and then we substitute these same values, negative 5 and so on, down to 7. For x, we will get the y values down here. So firstly, we will plot x plus y is equal to 25. From which, of course, we get y is equal to 25 minus x, which is this format of that same equation over there. If we plot that, we get this. Notice you have a straight line. Now, if we take the other equation, y minus 2x is equal to 10, then y is equal to 10 plus 2x. When we plot these points here, we get this equation. Again, it is a line. Y is equal to 10 plus 2x, which is the same as y minus 2x is equal to 10. We get a line. Okay. Now, let's put these two graphs on the same graph paper and see what happens. This is what happens. This one here is y is equal to 25 minus x. And this other one here is y is equal to 10 plus 2x. Note carefully the point where the two graphs intersect, which is here. That point is 5, 20. That is to say, the x-axis is 5 and the y-axis is 20. So that means that x is 5 and y is 20. X is 5 and y is 20. Well, this is one method of getting the answer, but this objective says specifically to solve algebraically. And what I just showed there was not algebraically, is graphically. Now, this graphical method was used just to show you what is meant by solving simultaneous linear equations in two unknown. But we use a graph to do that. The answers we get must satisfy both equations. In this equation here, y plus x is equal to 25. If we substitute 20 for y and 5 for x, do we get back 25? And the answer is yes. That's that equation. But it also needs to work in the next equation. Y minus 2x is equal to 10. Y we said is 20 minus 2 times x, which is 5. 2 5 is 10. 20 minus 10, is that equal to 10? And the answer is Yes. So the two answers we get must satisfy both equations. We will next look at two methods to solve these simultaneous linear equations algebraically. So first of all, I will demonstrate how to do that using these two equations we were looking at here. And then after that, we will look at 4 more examples. For your information, the graphs of a linear and quadratic equation, just in passing, that's a linear, like y is equal to 10 plus 2x, you get a line. And this over here is the graph of a quadratic equation, something like y is equal to 2x squared minus 2x plus 1. If you find this video useful and interesting, please like and share. That is, like and share. You may also consider subscribing to this channel. So as I said, the answer you get must satisfy both equations. And this was your introduction of how that can be done using graphs. But that is not our main concern in this objective. Again, for your information, this type of graph work is called linear programming that gives the optimum state under two different conditions. So method 1, substitution. Now remember when we did it by graph, we got x is equal to 5 and y is equal to 20. So now we will do it by substitution. So those are the two equations. We will rearrange any one of these equations to make one unknown the only item on the left-hand side. So we can rearrange this first one here, leave y on this side, and that x goes over the next side, it becomes negative x. So now you have y is equal to 25 minus x. We have rearranged the first equation to this. Now that we know that y is equal to 25 minus x, and we also know that y minus 2x is equal to 10, we could take out that y from there and substitute this because we said y is equal to that. So we will substitute 25 minus x for y in equation 2.